This lesson works through what we call type 3 polyatomic ion nomenclature. So the way that you can identify that something is polyatomic is that it ends with a ATE or ITE ending. It does not end with IDE. So if you have an ending with ate or ite, almost always you have a polyatomic ion that you're working with. So in this case here we have lithium and we have sulfate. You will have a reference sheet that tells you exactly what the chemical formula for sulfate is, but since many of you don't have it, I will tell you that. So it is SO4 with a -2 charge. Lithium, with our periodic table, we know that it has a +1 charge. So same concept as we've been doing before. With lithium, we know we have 1 valence electron. For these polyatomic ions, look at them as best friends, BFFs. They are always together, and because they're always together, they take on a unique personality that's unique to sulfate. So to simplify our drawing, I think the easiest way to deal with it is that we just write the chemical formula on there and draw the 6 valence electrons that overall are in sulfate. Now, this is not quite accurate. For those honors students, you know exactly how that's going to be structured, but it simplifies it. So the reason that I know that it has 6 valence electrons for this group of atoms is because it will naturally take on 2 electrons, and that's shown in the chart that SO4 always has a -2 chart. So here we have lithium that has 1 valence electron. It's going to want to get rid of it, where the sulfate has 6 valence electrons and it will want to gain 2. So in this case, lithium will give 1 of its electrons to the sulfate. The sulfate, however, still would like to have 1 more electron, and so it requires another lithium to donate that electrons, and there we have it. So this here would have a chemical formula of Li2SO4, and it would be called lithium sulfate. So we don't change anything in terms of the name. We always say the cation first, then the anion, and so in this case it's lithium sulfate. So here we have another situation where in this case we have calcium, that's Ca, and calcium, looking at the periodic table, is a cation with a +2 charge, and referring back to our polyatomic chart, phosphate has a -3 charge. Alright, so in this case, let's draw this out. Calcium has 2 valence electrons. We'll draw phosphate as one big group of atoms, and in this case it has 5 valence electrons. Calcium can donate 2 of its electrons to phosphate. However, phosphate is still wanting to have 1 more electron, so for that reason we'll have another calcium. And so that 1 electron will move over here. So phosphate has its 8 valence electron, but calcium still wants to get rid of 1 more. So we will have to add another phosphate, and remember it has 5 valence electrons, so 1 of those valence electrons are here. Calcium still has 2 single electrons. In other words, it wants to have 2 more electrons, and so we're going to put yet again another calcium here. And as a result, both of them have their full valence shell. So when I do my counting, it looks like I have 3 calciums. So I write Ca3, but then it also shows me that I have 2 phosphates. And to show that we are dealing with 2 groups of PO4, we do parentheses. So PO4 is placed into a group, and we have 2 sets. So it's key to have those parentheses. There's another situation where we now have a transition metal. So remember, for transition metals, the Roman numeral tells you how many electrons you have. So this tells me we have iron 3. Nitrate, when I look at my polyatomic chart, it shows me that it's NO3 with a minus charge. That means that it has 7 valence electrons. And remember, we're going to look at these polyatomic ions as just one group. So in this case, I have 1 electron going to 1 nitrate. And that satisfies nitrate's octet rule. However, iron still has 2 electrons that it wants to get rid of. So it means we need to have a total of 3 electrons. So in this case, this would be written as FeNO3, 3. Okay? So let's try now going backwards. So just so you remember, again, looking at your polyatomic chart, bicarbonate is HCO3. It has a -1 charge. This tells you that we have tin, which is SN, has a +2 charge. So in this case, we know that tin has 2 valence electrons. HCO3 has 7 valence electrons. There we go. And we can tell from our diagram that we need to have a total of 1 tin. And then again, we use those parentheses to show that we have 2 groups of HCO3 over here. That's the end.